Hey, this is Dr. Hines. We are actually going to blow up some stuff in Chem Lab. All the time, students are saying, can we catch something on fire? Can we blow something up? It's like, no, no, no. Well, guess what? This is going to be a yes, we will explode something in Chem Lab today. So what we have set up over here, we call this the micromole rockets. First, what we're going to do is we're going to basically kind of take a look at some properties of hydrogen gas and oxygen gas. And then after that, we're actually going to make little tiny micro rockets. And although we haven't covered stoichiometry yet, we're going to take a look at ratios of hydrogen to oxygen to see if there's a larger explosion compared to a smaller explosion. But anyway, let's just kind of take a look at the properties of hydrogen and oxygen. So I'm going to do the hydrogen gas. And one of the things that we're going to learn about in chemistry is that if you take a metal, most metals, if you react them with acids, and I'm going to use hydrochloric acid, reacting with zinc, when you mix the two together, hydrogen gas is a very common product that gets made. So this is how we're going to chemically make hydrogen gas. We're just going to take some zinc and hydrochloric acid. We're going to mix it in a little test tube right here. And you can imagine the reaction occurring inside there. And the little cork that I have, the little rubber stopper that I have on top, this is how we're going to actually collect some gas to make our little micro rocket. But first, we just need to see what kind of property that hydrogen gas has. So I'll just take a few small little pieces of zinc. I don't know if you've ever seen zinc before. Should I bother using my scapula or just pick it up with my fingers? But this is what zinc can come in many different, I'll say, shapes or forms. This is just crude, cheap, mossy zinc, as we call it. So I'm going to put 1 in here. I think 1 should be enough to do the job. So it's just down there in the tube. And now what I'm going to do is I'm going to add some hydrochloric acid. I don't remember how much hydrochloric acid I'm supposed to add in here. It's on a different page. I'm just gonna ad lib, and I'm just gonna add some hydrochloric acid to it. Do I need a specific amount of hydrochloric acid? I think we're supposed to use, as a general rule, let's just use about 1 milliliter's worth of hydrochloric acid in there. And how much is 1 milliliter going to be in this test tube? Am I going to measure it out in a graduated cylinder? No, here's a very crude rule of thumb. Rule of pinky, actually. See the width of my pinky? If I put about that much hydrochloric acid in there, that's going to be about 1 milliliter of hydrochloric acid. Does it need to be exactly 1 milliliter of hydrochloric acid? No. What's our objective? Acid, zinc, make it bubble, get hydrogen gas, okay? So here we go for some fun and excitement. Got our little test tube of zinc right here. Gonna put some little drops of hydrochloric acid in there. Do you see anything happening in there? Anything exciting going on? I hope so. Man, isn't it fizzing like Alka-Seltzer or something like that? Or soda pop. Yeah, we're making some soda pop in lab today. Okay, so it's making hydrogen gas. And I'm going to put this little cork on it, little rubber stopper on it. And the reason why I'm doing that is this tube it's filling up with hydrogen gas. But hydrogen gas is lighter than air. So if I take this rubber stopper off, all the hydrogen gas is just going to escape out of the tube. And I don't want it to escape. I want to keep it in the tube so that I can do the spark test result in this lab. And I think we're supposed to let this bubble for about 30 seconds. I haven't been timing this, but I'm kind of thinking that we're probably pretty close to the 30-second mark, okay? So I'm going to assume that this tube is pretty much filled with hydrogen gas. I don't want any air inside it. I just want hydrogen gas. All right, so here's how we do the spark test. We have these little wooden splints over here, and we need a spark, not a flame, a spark. So I'm going to kind of get myself ready here for this, and just to kind of talk about what's about to happen, I'm gonna light the splint, I'm gonna blow it out so it's just a spark, and then I'm gonna put it down in the test tube and we're gonna see what happens. So that's kind of a little bit of prelude of what's gonna happen here. So I'm just gonna move my test tube over here. I'm gonna light my little wooden splint. Okay, I'm gonna make sure that I definitely got a spark on it. Okay, so you see it's got a spark on it. Try to put this here up close so you can kind of see what's gonna happen. Is it gonna explode? Is it gonna blow my fingers off? I don't know, I hope not. Okay, so here's the spark test. Well, gosh, did you see what happened? I see the spark went out. So, in your little lab report, okay, I don't know that we're gonna do multiple trials here, but for trial number 1, what was the result of your spark test with hydrogen gas? So you need to record what was just observed right there.